Okay, so let's take a look at example 1D here. We have a regular pentagon with a radius of 5 that we need to find. So let's just first start off by making sure we remember that in order to find the area of a regular polygon, we can use this formula: area equals 1/2 apothem times perimeter. So there's two things that we need to know here. We need to know the apothem, which of course is that distance from the center of the polygon down to a side. So let's go ahead and draw that in. This would be the apothem. And remember, that makes a 90-degree angle with the side of the polygon. And then secondly, we need to know the perimeter. Now the perimeter of any shape is equal to the total length around the shape. Since this is a regular pentagon, we can just take this side length here that we see. We can take this side length and we can take that times 5. So if we can figure out the apothem and the side length, then we can find all the pieces that we need to know in order to use this formula here. So let's jump in. Let's start by finding this apothem. Now, I notice that this is a regular pentagon. So if I take the number of sides minus 2 times 180, that would give me 540 degrees, which is the total for all 5 angles in this pentagon. If I take that 540 and divide by 5, then each of those angles is going to be 108 degrees. And that means that in this right triangle that I can see right here, then the angle down here is going to be half of that 108, which would be 54 degrees. And so that means that with this right triangle, I should be able to use some trigonometry, some SOHCAHTOA, in order to find the two missing sides of that triangle. And if I think about that, obviously the one missing side is the apothem itself. So when I find that apothem there, that's going to be one piece of my puzzle that's going to go right there in my formula. Now the other missing side, let's call it an x right there, that is going to be half of one of these sides, because I'd have an x there, and then if I drew another triangle over here, that same length would show up right there. So if I just add those two x's together, that's going to be my side. So this side length is going to be x plus x. So let's go through and use our trigonometry to find that a and that x value in my picture. So let's start with the sine, or let's start with the a. And in order to find the apothem length, what I'm going to use is the SO part of SOHCAHTOA. I'm going to use sine, because that a is opposite the angle that I'm going to use, and I have the hypotenuse. So if I set up an equation with sine, saying sine 54, then it would be equal to opposite over hypotenuse, and you can see in that equation I have just the one variable, so I should be able to solve it. So I'll say that a equals 5 times sine 54, and that's going to give me a value of a which is about 4.0. So again, that's going to go right up there in my formula. Now let's find the x. To find x, I'm going to notice that that is adjacent to the angle. And again, I have the hypotenuse. So that's going to lead me towards using cosine. So I'll say cosine of my 54-degree angle equals x over 5. And then x would be equal to 5 times cosine 54. And that's going to give me a value of about 2.9 for x. So with that value of x, I should now be able to find that side length. So my side length is going to be 2.9 plus 2.9. So that's going to be 5.8. So the perimeter would be 5.8 times 5, which is going to be about 29. So I have an apothem that's going to go right in there to that formula, and I have a perimeter value that's going to go right there in my formula. So the area of my pentagon will be 1/2 of 4.0 times 29. So I'll go ahead and say half of 4.0 is 2.0 times 29. I didn't mean to put a decimal point there. Let me get rid of that. Times 29. So the area is going to be about 58.0. And that's how we do example 1D.